This is Unit 11, Acids and Bases, Lesson 3, pH and Indicators. How is pH determined? The objectives of this lesson: I can differentiate between an acid and a base on the pH scale. I can determine the change in hydrogen ions, or OH, hydroxide ion concentration during a change in pH. I can determine the pH range using the indicators on Table M. Do now. The pH scale is a direct measurement of the hydrogen or hydronium ion concentration in a solution. This measures how acidic or how basic an aqueous solution is. The pH scale ranges from 0 to 4, from acidic to neutral to basic, and this is determined by the ratio of hydrogen ions to hydroxide ions, and that determines the pH. In acids, the hydrogen ion is greater than the concentration of the hydroxide ions. In bases, the hydrogen ion is less than, the hydrogen ion concentration is less than the hydroxide ion concentration. When it's neutral, the hydrogen ion concentration is equal to the hydroxide ion concentration. So each change of a single pH unit signifies a 10-fold change in pH concentration of hydrogen ion concentration. And this is really important. So star this, memorize this. So basically when I go from 10 to 11, that's a 10-fold change. So for example, a solution with a pH of 3 is 100 times more acidic than a solution with a pH of 5. So when I go from 3 to 5, that is a 100-fold change, 100 times different. So practice. So how the pH of 4, which is here, is how many times more acidic than a pH of 6? So every time I go 1, that's 10. Every time I go another, it's 10. So it's 10 times 10, which equals 100 times more acidic. So here are some pHs of common acids and bases. Battery acid is very acidic. Lemon juice is very acidic. And vinegar is very acidic. Milk is almost neutral, but it's a little tiny bit acidic. Baking soda and seawater are a little bit basic. The milk of magnesia, which is like an antacid, is basic. Ammonium is very basic, and lye is a base. This is part of how we make soap during saponification. I did it again. Soap. There should be a O. I'm trying to write saponification. So for example, if I add 1.1 molar sodium hydroxide to a 0.1 molar solution of HCl, this will cause the pH of the solution to do what? It will increase because I'm adding OH, hydroxide ions. So acid and base indicators are on Table M, so get out your reference table so you can look at Table N. An indicator is a substance that changes color as a result of a pH change. These are used to determine if a solution is acidic or basic, or to narrow down the range of a pH of solutions. So using Table M, if the pH is lower than the left-hand number, it will be the color on the left. If pH is higher than the right-hand number, it will be the color on the right. If the pH is approximate range, will be if it's in between the two colors, or in between the two ranges, two numbers, it will be a blend of both colors. So for example, methyl orange turns red with a pH of 3.2 or lower. It turns yellow with a pH of 4.4 or greater, and therefore it will be orange if it has a pH in the middle of the range, so between 3.2 and 4.4. So that's a blend of red and yellow. So using multiple indicators to narrow down the pH range, for example, a solution will turn blue with bromocresol green, which means that if it's bromocresol green and it's blue, I have a pH that's greater than 5.4. So here's bromocresol green. And it will be yellow, so the same solution is yellow if I use bromethymol blue. So here's bromethymol blue, and it's yellow if I have a pH less than 6. Therefore, the pH range of that solution is between 5.4 and 6.0. So another example, a solution turns yellow with thymol blue and blue with bromethymol blue. What is the pH range? So thymol blue is here. If I'm yellow, that means I have a pH that is less than 8.0. If I'm blue with bromethymol blue, I have a pH that is greater than 7.6. Therefore, my pH range is 7.6 to 8.0. So check your understanding. And now you can differentiate between an acid and a base on the pH scale. You can determine the change in hydrogen ion or hydroxide ion concentration during a change in pH, and you can determine the pH range using the indicators on table N.